My name is Kim Stacy. This is Allison Smith. We're with Chittenden Solid Waste District, Organics Recycling Facility, home of Green Mountain Compost Products. Long name, everyone knows us as Green Mountain Compost. Just a little bit of a background and kind of laying the land of our site. Well, actually, we're going to talk about our contamination control measures that we've seen over the last decade or so, kind of a culmination of a lot of different things from equipment to different, our contamination policy that we put into place just this past year. So a little bit of background. We are Chittenden Solid Waste. It's about 19 towns in Chittenden County. It encompasses 169,000 residents and 8,900 businesses. Last year, we processed about 19,000 tons of organics, which equals, from that, 4,500 tons of food scraps and 11,000 tons of yard waste. I do want to kind of make a little bit of note about that yard waste number. It has doubled in the last year, and I believe it's because in the last year and a half, we changed our incoming stream of yard waste from just leaves and yard waste to a commingled leaves, yard waste, and wood waste, because now we are able to shred that on site. So landscapers love it, and residents love it because they don't have to go to different locations to drop those materials off. So we get all of our food waste. I was doing this on a smaller screen yesterday, and I was like pointing to it, but now it's huge. So let's see. There we go. All of our yard waste drop-off is right here. Our food waste gets dropped off here. We have about 10 commercial haulers that haul food scraps from local businesses and residents. We also have residential drop-off right here. The residents can also drop off at 6 of our different drop-off centers in Chittenden County. All of that material does get hauled to our facility. We then process it in a month in our phase 1 and phase 2 aerated static pile systems. We pre-screen it to a 2-inch minus material that then gets hauled down to our curing area. It's in our curing area for about 2 to 4 months. We windrow turn it weekly. Once that's finished processing, we then finish screening it on a Star Deck screener to 3/8 inch. We do have overs at different sections. So in our 2-inch minus over here, we have overs that come out here as well as down at this area, and I'll go into a little bit more about that in the future. This is a timeline. I'm not going to go into this because we touch base on this throughout our entire presentation, but I'm going to talk about specific equipment purchases that we've made and process modifications that we've created over time. Allison's then going to go into some changes to our organic stream that we've seen over time and our specific contamination policy that we've created and implemented this last year. So it all kind of starts, we did a huge site expansion back in 2018, 2019. We purchased this windrow turner. It is the most awesome machine. Got rid of 5 other pieces of equipment. Super efficient piece of equipment because it allows us to blend our incoming food scraps, turn our curing area, as well as blend finished product like topsoil and garden mix. But at that curing phase and I guess the blending phase at the start, it kind of shreds up all the material as it's turning it. So prior to this equipment, our curing process was done by an excavator, so it just flipped the material over versus shredding it constantly. We also use this to turn our curing area weekly. So the excavator would take up to 2 weeks to turn our curing area. So 2 hours with the windrow turner, 2 weeks with the excavator, shredding versus turning. It added to our plastics problem. So all of our our compost that was finished that we were bringing down to our curing area, previous to the windrow turner, it would just kind of sit, and then we would screen it afterwards to 3/8 inch. We would get a large overs pile, but the plastic was kind of staying in place. So what we did, we had to look, this is what happened when we got the windrow turner. Keeps turning the pile, bringing all that wind-blown plastic every single turn to the outside of the pile. Once wind kicked up, goes crazy. That's Andrew right there in this video. It's backbreaking, and it's also just illuminating at the issue. We need to go back to the start, look at our process before it comes to the curing area, and see what we need to do. Number one is figure out a policy, educate customers. Number two, we need to pre-screen the product before it gets down there. So we did get a trommel screener. Sorry, it's a little off, but we got a trommel screener and we got a wind sifter. So this wind sifter actually came a couple years after we got the trommel screener. All of our finished compost, before it goes to the curing area to cure, goes through this screener, is screened to 2-inch minus. All of the overs come out, but while it's on the conveyor, the wind sifter is able to pick out plastic from it. This is like the ideal moment right here. And we've just had this ability just in the last year with the wind sifter. So once we screen to 2-inch minus, it goes through the wind sifter. We'll then put the overs back through the process again, taking out more contamination, and then we're able to put that overs, cleaner overs, back into our yard waste pile where we are able to shred it. So this is what it looks like pre-wind sifter, which we just got the wind sifter, so we do have a huge overs pile that we do need to still process. But this is after the wind sifter, so much cleaner. We're able to recycle that back on the front end, put it through our screener. I did skip one step where we do lay that pile out and hand pick. So we are hand picking before it goes back into our yard waste to be shred to 3-inch minus. That being said, we did get a shredder. And prior to the shredder, we were outsourcing our grinding process. It does not give us control on timing of shredding. Also didn't give us control on the type of material that we're getting from the shred, so it was very inconsistent. Larger pieces were coming through, and which ends up in our overs pile at the end being a lot larger. So let's see. Again, previously anything over 2 inches was included in our final overs needing landfill disposal. And moving forward, we are able to size all incoming wood to be large enough for good porosity and small enough that it will not contribute to the overs burden. That's on the front end before the curing process. On the after the curing process, when we screen to 3/8 inch, we do have some wood fraction that does make its way through the process that we are able to now age for a couple of years. We then are able to screen out the fines from that after a couple of years and recycle the wood chips back into our front end process. So it just gives a little bit more time, and we're able to get a lot of product out of that and make it into topsoil. So just a really quick recap. These are all the pieces of equipment that make it possible. From the front end, our shredder gives us the ability to shred pieces down to a size that make it their way through our process much better. Our trommel screener with the Aris wind sifter, that's like the magic bullet right there. Takes out all the larger wind-blown plastic before it heads down to that curing area. And it also cleans up our overs, which we can then recycle back. Our windrow turner, just, efficient, but also leading to the problem. And then our Stardex screener, which allows us to get those aging mids that we can then recycle. So this is kind of a quick overview of that, but Allison's going to take it away with.
Yeah, so all of these changes are kind of engineered to get rid of contamination at several points after the food waste has been tipped. A lot of the work that I do with CSWD is to control some of the changes to incoming organics. So this is trying to get rid of contamination as it's tipped to our facility or even before it comes to our facility. I love this picture of food waste. It's really dynamic. There's like a nice scattering of ham just across the middle. It doesn't have a lot of contamination. I don't have all the food waste that looks like this. A lot of the food waste pictures in this presentation do not look like this. But even this one, this beautiful one, oops, looking for the laser pointer. There is a small Craisins container right in the bottom. So even this beautiful picture of food waste still has a little bit of contamination in it. So Act 148 did, as it relates to changes to incoming organics, so Act 148, we saw an increase in the organics that were being tipped at our facility. But with that, we had people that were not previously bought into composting, bringing their organics to our facility. Schools are really hard for us. We want to get kids involved in composting. We have an education outreach person who works for CSWD, Rhonda, who's here today. She's really great at outreach to schools, but all this contamination is because there are 3 bin sort systems in places where there weren't previously 3 bin sort systems. They're used to trash and recycling. As these bins fill up, you know, you start getting a chip bag, you're going to get another chip bag, you're going to get more milk cartons. It just proliferates the problem. So that Act 148 fully rolled out in 2020. In 2022, we had to make the decision to stop accepting compostable materials other than liner bags. Liner bags we have found really help people to compost. They want to line their totes with liner bags. We do find that they break down as long as they're internal to that pile. A lot of the film plastic that Andrew was blowing around is conventional plastic. So as long as they're certified compostable liners, we want to take those. The problem with compostable food serviceware that we have found is that it leads to conventional plastics being in your compost. It's not that the compostable materials don't break down, it's that it leads to more contamination. This is a great example of that. There are some compostable cups in the corner. If this was in the same bag, which I do a lot of load checks, you start to get a little like detective-y about the food waste that you look at. I don't know if any of the other composters are like that, but it is, you see some compostable products, then you see some conventional products, and it gets worse and worse kind of as you go through that load. And it's easy to see if a business is having compostable cups, a customer might assume that everything that they have is compostable. That's not always the case. This is another picture from a school load. These paper products are not certified compostable. They probably break down in our system, but you can see that contamination is coming in with them. This is another one. You can't really see it all the way on the far side of the screen from me. There's a bunch of plastic forks. All of the front and center are all the compostable plates that came in there. Would we have gotten all those forks if people weren't putting their entire plate in the compost? Who knows? Contamination policy. I am going to touch on our actual contamination policy, but as it relates to incoming food waste, we have found that having a contamination policy on the books that has punitive fines has really improved the stream of organics coming in. When you put a price tag on an email that you're sending to a hauler, they're going to respond to you and they're going to change their habits. We also started doing some self-hauling. As Kim said, we have about 10 commercial haulers that bring their material to our facility. We wanted to get into that game as well so we can control all elements of that hauling program. We can control the staff training that we're doing. We're picking it up ourselves, so our drivers are the ones interacting with the toters, and then we're able to control that entire stream. We also wanted to make sure that we're partnering with businesses that are they are bought into having clean organics. They understand what we're doing here. They understand that composting is really important and that having clean compost is better for everyone. All right, now we're going to get into the actual contamination policy that we landed on. Didn't want to hold you all in suspense. This is the basic flow chart for our contamination policy. This flow chart had a lot of different branches. There was different colored boxes. There was different timelines that we wanted to implement. This took a lot of work to make a fairly complicated flow chart. There's 3 different kind of buckets that loads can fall into, and we went with a volumetric system, and I'll talk about that in a second. But this was a long process for us. We wanted to make sure that we were involving other composting facilities to see what their successes and failures were. We also had to relate it to our staffing and figure out what we were able to accomplish, and then what CSWD with our outreach staff, how we could get everyone involved to make sure that this effort was successful. So we rolled this out on July 1st of 2024, so it hasn't been even a year yet. Like I said, the organics that are coming in have improved, but this was a lengthy process. We started by counting every single piece of contamination that was coming in on load checks. This took forever. It makes for some really cool pictures, but this is a lot of time on the tipping floor. This means that you're taking up operators' time because they're waiting for you to get out of the way, and you also have other haulers that are trying to use your facility at the same time. So by piece data collection, Craig Coker, who's a compost consultant, he has this great adage that you can't manage what you don't measure. So this is us measuring exactly what is coming in to our facility. Very quickly, we abandoned by-piece data collection. We did a lot of these load checks, as you can see, and we moved to the volumetric thresholds. Volume for food waste is really, really difficult, though, because we're getting source-separated organics from a variety of different locations. It might be, big bags of just kale stems, or it might be that cafeteria load that we saw. We needed to make sure that we were hitting these benchmarks on our volumetric threshold for all the food waste that was coming in so that you could do load checks really efficiently and effectively. And all the way down to this last box, we needed to know what was realistic for our feedstocks. We are a municipality. We want to make sure that we're handling the organics stream as efficiently as possible, but that also means that we want to be accepting as much organics as we can. We don't want to be rejecting a lot of loads, sending those to the landfill. We want to be composting as much as possible. This is an equation that we came up with by doing all these load checks, by measuring food waste as it came in. Again, this equation relates to the feedstocks that we're seeing at our facility. We've tested this again and again, and this is a pretty good idea of what the volume of food waste is being tipped based on its tonnage, so that we can very quickly remove contamination, put it in hopefully a 5-gallon bucket, maybe a 32-gallon toter, and we can relate that to the percentage of the contamination removed from that tonnage of food waste. We take a lot of pictures of, my personal cell phone has a lot of pictures of food waste on it because we want to make sure that any questions that we get about how we're reaching our benchmarks for a contamination policy are backed up by data. So this was all established during our data collection phase, and that's how we got to that 5 to 10% contamination, which is our first level of fined loads. For reference, our tipping fee is $70 a ton, so this is a little more than doubling that tipping fee. So they hopefully feel it in their pocketbooks. And this is the kind of load that most of these bags are filled with beautiful organics. This is going to be, again, from a school load. Since we don't take compostable materials, we do count that as contamination. So we don't want these soup cups. As soon as it's tipped, you can kind of be like, well, this is over the threshold. I've seen enough food waste. I know that this is over that 5% load. From here, I would take all of those all of the contamination that we see in that load, put it into either 5-gallon buckets or, again, that like 32-gallon toter, and then double check my work so I know that I'm in that 5 to 10% contamination range. Over 10% contamination is when we would maybe reject a load from the facility based on personnel, based on what the load is, how much time we have, et cetera. We did pick this load. This is actually a local depackager, was closed that day. A grocery store brought their items to us instead, and we were still building the policy, and I wanted to see how much time this took to pick. So we wanted to go through the entire process of removing all the plastic from this grocery store load. Over 10% contamination does not look like it should be at a composting facility. You know it right away. It's not supposed to be here. So this is just some more pictures from that load. This is, I wish I could show this to all the haulers of like picture this being struck by a windrow turner, that all those plastics get shredded up. Over 10%, like I said, does not happen very frequently. We have had to reject a couple loads, and it's $150 per ton. So now you're paying 3 times our tipping fee if you bring this to our facility. Whether we pick it or not, if we reject this load, it's still $150 a ton. Outside of that volumetric threshold, this is something that came out from that by-piece data collection. So these are things that we've seen in our facility. They're never going to hit 5% contamination. If I get 5% of 5% glass bottles in a food waste load, something has gone extremely wrong. But if I get 3 glass bottles, or a bag of recycling, or a bag of trash in a load, we still want to flag that for our haulers. We want to say, hey, we really don't want this. We really can't handle a bag that's full of PPE in our compost. So outside of those volumetric thresholds, loads that are even accepted can have a $50 ding on it. We just want to bring their attention to, hey, you dropped this off at our facility. We really don't want it. It's really problematic for our processes. Some successes that have come out of this, like I said, I take a lot of pictures. Sharing those pictures with haulers has been so important to getting that communication across. We use a cloud-based service. All of the haulers have access to just their folder. It's organized by truck. It's organized by date. We have a load report in there so they can see exactly what we're seeing. I have pictures of everything I've taken out of the load. Again, if we get any questions on, hey, I think you're only checking my load, or hey, I don't think I did that, I have pictures with timestamps that show them, yes, it was you, yes, we don't want this material. And we do this for loads that are accepted too. The vast majority of loads that I check are totally fine, or maybe they have a couple chip bags, etc. Again, this is just an example of going through our load report, having a really clearly formatted load report. We have a wonderful IT guy, John, who was able to build this for us. It makes doing the process of load checks really easy as well. So there's not that kind of benchmark of like, oh, I don't want to have to go out there. Oh, I don't want to have to do all the data management. Streamlining this as a composter is the golden bullet. It's going to make sure that you continue to do load checks, because contamination policy is not something you roll out and you say, done with that. You have to continue to do it. You have to continue to reinforce it. And the more streamlined it is, I can train people how to do this. I can get other people to do load checks. Everyone's doing the same load checks with the same benchmarks of what they're looking at. And it's really clear for the haulers, and it makes it a much more clear system. This is also tied to our scale software. So when they get their end of the month billing report, all of their contamination fines are rolled into that. It is part of using our facility that you are abiding by our contamination policy. We do have some continued challenges. Like I said, you have to continue to maintain a contamination policy. I would love for a future where those benchmarks of 5 to 10% or over 10% get smaller. That's not in the cards right now. Again, it's just been a year. But some of the continued challenges we have, we are the end of the line for organics, so all of our communication goes to the hauler, which then we have to encourage them to reach out to their generators. We do have an outreach arm at CSWD. They do a ton of outreach. But that's always going to be the struggle of, you know, if a load comes in today on Wednesday, I can't talk to the business that it is because I don't know the business that dropped this off. The hauler dropped it off, and I have to let them know to let the business know, etc. The other problem is routes that have a lot of stops. I don't have a good follow-up for haulers who, you know, they have 100. They're trying to be as efficient as possible. They want to be efficient with their personnel and their equipment and their time. So of course, we want them to do as many stops as they can, bring all those organics to us. If I ding them for having a bag of trash in a 7-ton load that has 100 stops in it, I don't have a good answer for them for how to do outreach for that. So still continuing to work around some of these problems. I think that engaging with haulers or whoever is bringing your organics in, that is really how you're going to get people on your side. We want these haulers to know what we're dealing with. We want them to know like how much time we commit to dealing with contamination when we're really just trying to make a beautiful soil amendment. It's really that struggle of where your time and resources go. All right, that's all I have. I think we're going to do questions for us. Yeah.
real quick, we are touring our facility tomorrow from 2 to 3 o'clock. So sign up if you want to come take a look at all of this and ask us questions. So, yep.
You haul from the transfer sites where we're dropping off on compost. Is it your staff that's hauling from there, or do you hire haul?
Yep. So her questions, I asked to repeat the questions. Her question is, do we haul from our transfer sites? Do our staff do that? And that, yes, we do. Yep.
Of money and time and people energy on fighting contamination. What are your compost sales like? Are you making a profit? Are you breaking even, or are you under?
So just starting around 2020 is when we started to kind of break even. I think maybe 2020 was the one year that we might have been in the green. But we used to get a subsidy prior to that, heavily subsidized, but now we're kind of breaking even. So, yay, hopefully.
Do you have a goal for, like, how many average tonnage did you say you had? 19?
Last year we did about 19,000 tons. Yeah.
Can you estimate what percentage?
Between commercial and residential. So the question is if we can differentiate between how many food scraps are coming in for residential versus commercial. And it's funny that you say that because I was trying to answer that quickly in my head yesterday, and unfortunately we can't track that. I could probably work on that, getting that information, because I just have to get the tonnages that are coming in from our transfer stations. And then the only issue is that there are some haulers that do residential and commercial hauling, and they don't specify where they're coming from. So it would be kind of not a super accurate count. But
Most of the recycle or the composting that's coming in to those 6 transfer stations, generally residential, or is it really?
I would say probably 95% residential, unless there's like a small business that's nearby and they want to come. But again, we don't have access to that information. So, yep.
Any demonstration gardens where you're using the compost product to see if you're having any problems with the
That's a great question. So the question is if we have demonstration gardens to see if the compost is truly acting the way it should be. We actually do test every batch of compost that goes through. We put it in our greenhouse, and we do a bioassay. So we test on, mainly it's a persistent herbicide test, but we're able to see, we test fava beans and red clovers. Those are the most sensitive to herbicide damage and heavy metals. Sorry. She's really good at tours and knows all the information. So we do that in our greenhouse, and then just last year we started some test beds around the site, and we'll be doing testing on all of our garden mix batches. So we do know that our compost is safe, and we have not had any issues since 2012 in the persistent herbicide area. So I'm sure is that where the question is stemming from? Yeah. We're also very careful about the manure that we get in, the horse manure. So we only get in from one hauler. Maybe there's a couple other ones, but we vet everyone who comes in and ask that they let us know where their hay is being sourced from, and their feed, and so yes, we're very careful now. Jason?
Waste separation before the ASC or after?
It's after. Yep. So after the first 2 active phases, we will. We now are doing. This is just in the past couple of months, though, that we've had time to set it up. That Eris wind sifter is actually it is bulky, so it took us a little bit of time to figure out the right configuration. So there was moments where we could only set it up and process overs, and then there was times that we had to quickly screen our phase 2 or our finished compost to get it down to our carrying area. So we couldn't set up the Eris in that moment. So we did some kind of shifting, and now we have it set up at all times at that spot in our site. So yeah.
Herbicide contamination. You don't do any I mean, that would, what you do, what you said would detect a problem, but that's after you make a compost.
Correct.
Things with the lawn,
If we,
lawn waste, I mean, that's always my concern. Composting lawn waste is bringing
Yeah.
heavy pesticide, both herbicide and, insecticide.
yeah, unfortunately, just the way that we are set up, I think if we found any instance of damage in those plants, if we were seeing any persistent herbicide damage, we would not sell the product. So that's kind of our safeguard. Unfortunately, it would be a huge disaster because we'd have all this compost that we couldn't use, but we haven't had to we haven't really dealt with that issue yet, so it hasn't been a problem that we've needed to go on the front end for. So
I mean, it would take a really heavy concentration before it would, a huge tonnage of material coming in from a lot of different sources. Take a really heavy contamination before you even have a bioassay fail.
Right.
You could have a human safety issue at much lower levels.
yeah, I guess I'm not sure how to answer that question. We
Drive that do remediation of contaminated soils? Like, is there any micro remediation or anything you can do when you have a load that you can't sell?
Not that I'm aware of, but I'm not sure if anyone else can speak to that in this room, since we are part of the community of composters. Anyone? No. Yeah, unfortunately, I don't know if anyone's doing that work.
Herbicide breakdown during the composting.
Not that I haven't been shared any information on that, but Brian?
Trying to speak to historically, most.
Question about the breakdown of herbicides and pesticides. So before persistent herbicides came out as a new category, historically the composting process was observed to break down those conventional or typical herbicides and pesticides where they would not show up and have residual impacts. But this category of persistent herbicides and clopyralid and a few other picrolam and a few other brand names were had unique properties where they would survive the decomposition process. They were very effective for killing broadleaf weeds, but they would continue to kill broadleaf weeds and tomatoes and peppers, I guess the nightshade family. So there was a specific category. They are no longer approved for use in landscaping in Vermont and many of the Northeast states. So their introduction is often due to alfalfa being imported for horse feed or other livestock feed from western irrigated plots. So there are pathways where that gets into these municipal or commercial systems, but they're less likely than they were in the past. And I think the other thing, and this is from work Dan and Goosen and others have done, is incorporating some biochar or high carbon like ash as a small percentage in the compost mixture has somewhat of a binding effect where at least I have not heard of reports of persistent herbicide damage in the last 5 or 10 years. So, or they're certainly less frequent.
So we do incorporate about 2 to 3% high carbon wood ash into our recipe, and that has, I think it's helped. Or it's just a safeguard, really. So, yeah. I wish I could speak more to that. It's making me want to go back and start doing some more research on my time.
Is that it helps retain nutrients in the soil from being leached out. So it's a good addition from that perspective.
Also heightens our pH, though. That's been it heightens our pH, and so that's been a kind of who put too many buckets in this time, or did you? So what?
Give a way of like working with that?
It's been not with our compost. We haven't. We actually did try to add some what was it? Elemental sulfur, and that just it. I don't think the way that our curing stages happen, our temperatures were too fluctuating to create the correct atmosphere for that breakdown to happen and to make it effective. But we are, I mean, I know compost is known to have a higher pH, so it's generally mixed with other like it's an amendment, so it'll be mixed with other soil products that have lower pH, and that kind of balances it out. But our problem with our topsoil and our garden mix is that our access to sand and silt, our sand and silt right now are, upwards of 8.2, and we haven't been able to source anything locally that is a lower pH. So we don't really have an answer for that, but we haven't found that it's been an issue for growing out in the community. So, yeah.
Great. Well, thank you so much to Kim and Allison. All right, so next we have Wyndham's solid waste compost facility with Bob Spencer and Brian Jaros.
Well, thanks for attending our session. After Chittenden Solid Waste, we believe our Wyndham Solid Waste compost facility is the second largest in terms of throughput. But we're somewhere, our permit allows us up to 5,000 cubic yards of food scraps per year. And we're probably in the 2,000 or so range. We weigh our throughput by tons, so we use the conversion to report to A&R what our cubic yardage is. Permits written in cubic yards. And that's because most compost facilities don't have scales. So anyway, I'll introduce our team here. Brian Jaros is the founder and president of AgriLab Technologies, which has a proprietary aeration and heat recovery system. In the audience is his engineer, Jason McCune-Sanders. And at Wyndham Solid Waste, going back almost 7 years, we started to look into setting up a new compost facility. And we're going to tell you the evolution of that. So, Brian, here.
All right, thank you, Bob. Thanks, everyone. We'll go through a number of slides with a lot of images of both the design development process and as well as the construction, implementation, and now operation. First up, Bob, I'm going to hand it back to you so you can point out to your facility.
Sure. We are located adjacent to a closed landfill, which is now covered with solar panels. And this approximately 3 acres is where we've been composting since 2012. We have another, I'll advance it. We can advance it. Another image showing our site. We're right along the Connecticut River, and that landfill without solar panels is the green strip between the buildings and what's called Old Ferry Road, because back in the 1800s that was a ferry across the river. So it's Old Ferry Road. Interstate 91 is to the east. We also, so this is pretty much all our property. The red bubble is the main MRF, which is no longer processing dual stream recyclables, but we have an office and a conference room there, and we bale cardboard. And then you can see Rich Earth Institute listed. They are leasing space from us. They're a urine recycling business located on our site that we're working closely with. And then we have the closed landfill, which is now solar array. It's actually the largest group net metered solar array in the state of Vermont. It's 5 megawatts, and we have about 20 off-takers that subscribe to that power. And it's actually a very good revenue generator for the district. From a landfill that we couldn't do anything with, we now get $120,000 a year lease from the solar company. It's privately owned. And we also get 50% of the renewable energy credits. And that was $140,000 last year. So over $250,000 of revenue per year is coming to the district through the solar array. Plus, we don't have to pay our engineering firm, Sanborn Head. Where's Tim? The solar company pays them to do the landfill inspections, and the solar company mows the landfill, which we used to do. So it's been a nice change for us. So we take in leaves from the town of Brattleboro, but it's only 4 days a year, 2 Fridays in the spring and 2 Fridays in the fall, so we don't get a large volume of leaves. And carbon is a problem for us, getting sufficient carbon to mix with the nitrogenous food waste. So one of the things that we accept here is all types of soiled paper and cardboard and waxy cardboard, and that's mixed in with the food scraps. That carbon we're getting paid for as a tip fee, and it provides, I estimate it cuts in half the amount of leaves or wood chips that we would have to use were we just going straight food scraps. So we are, unlike some compost facilities, we're sticking with the paper and cardboard, and God forbid it's a PFAS source. But we're looking at that along with A&R. What are the sources of PFAS coming into our site? That's a whole other thing we could spend an hour on. Next. We are taking in from a whole variety of commercial, residential, institutional, and industrial sources. We have food manufacturers, we have restaurants, we have almost all our schools, colleges, campuses, have really a mature organics collection business in the Windham Solid Waste District, with 5 different haulers doing collection. So AgriLab is, we did a request for proposals for a aeration system, as I mentioned, with heat recovery, and we had just 2 bids, and we picked our Vermont neighbors.
So just to add to that, we're a small team based in the northern part of the state. We're set up as a farm equipment manufacturer with the state of Vermont, but we do quite a bit of design, planning, installation, and then ongoing support work. So there's a lot of services related with our business. As part of that, we even jointly operate an on-farm composting site in the town of Fairfield with the Magnan Brothers Dairy. But we've while we started with most of our projects were on livestock or dairy farms, just the nature of growth in this industry, more of our clients in the last 8 to 10 years have been either private commercial sites, municipal or institutional facilities, and we're starting to get projects further out of the region now. We talked about compost aeration and heat recovery. This is just an illustration to describe that process. Our equipment would be what's shown here at the center, pulling. Typically negative aeration is when you're in the suction mode, positive aeration is when you're pushing air and oxygen up through the compost. But primarily we're using negative aeration, drawing the hot vapor out of the compost pile through our equipment. Some of these systems have a dedicated specialized heat exchanger on them. Some, in this case, the one in Brattleboro does not have that feature yet, but then we can also recirculate that hot vapor back into adjacent batches, and that we'll get more into that later, or we can direct that vapor out the exhaust into a biofilter. So if you've got food scraps, grass clippings, certain feedstocks with higher odor potential, in addition to things to manage the process well, you have this ability to scrub the exhaust through a wood chip or other high carbon biofilter at the end. In those systems that do have the heat recovery on board, it's much like solar thermal or geothermal, where we're circulating that hot water into a greenhouse, the radiant slab of a shop or building, or on some of the farms' wash water. Here's another illustration of it, what it may look like on a site. There's your compost piles off to the left. This would be what we would call extended aerated piles, where a number are in line with each other, adjacent to each other. We have other sites where they're laid out in separate windrows. So that's more dependent on the site constraints. But then again, we're drawing that vapor into the equipment. The blowers, other controls would be in here, and sensors. And then the vapor can either go back into a pile or to a biofilter, and then any hot water fluid recovered from the system can go and heat up a building. So there's a little background and why we think we were chosen to help on this project. So back to Wyndham with that background. As Bob mentioned, this process started a number of years ago as they were approaching their permitted capacity. They were victims of their own success. They had more food scraps coming in than their relatively small site was able to compost with a turn windrow method. So the goal was to not have to move the facility, keep it on the solid waste district grounds, be able to increase the process productivity, meaning shorten the cycle to get from raw feedstocks up to finished compost, and if possible, add heat recovery. Developing a plan within a budget, certainly a challenge. And if you recall, in this last 7-8 year period, we've had a significant inflation during and after COVID. So some of the original plans that were in the phase 1 had to be scaled back in order to meet the budget that they had. And then, as Bob mentioned as well, it needed to be in compliance with not only their solid waste permit, but other stormwater permits associated with other activities at the site and stormwater rules. So there was a few things in play all at once, and multiple partners were needed. At the conceptual design level, so this is more of the budget and original layout stage. Went through different iterations, so Jason would do these drawings on our team, and we'd go back and forth to look at the batch sizing, what were the volumes that the district needed to process, what was their typical weekly frequency, what was their seasonal or surge capacities. So try to take in that information to develop a batch process that matched what they expected to handle and what they expected to need as they continued to grow. Working with Sandboard head, Tim Pettit, and his team, looked at the pieces of more site-specific aspects. What were the existing elevations at the site, And in order to accomplish both the management of what would be considered clean stormwater off roofs and upslope areas, as well as the process water, meaning water that came in contact with active compost or older compost, needs a higher level of treatment. That green highlighted area is a vegetated treatment area, and we'll get into that a little more later, but that was relatively small given the area for the aeration of compost phase and then the curing piles. So that was another challenge that the team had to work through. So after all this, got all these plans on paper, the numbers start to look like they make sense. So we need to go in the field and check this. Does it actually work, not only with the physical spacing, but how you would expect that equipment to move through the site. So when haulers come in with their loads, are they driving, crossing traffic with loader operators on the site? Are there low spots that would be prone to tough driveway conditions? So kind of reality checking what's on paper. So, and Bob, chime in where needed, but basically the existing permit was for a small facility, so needed to go up to the medium category, and that required higher level of treatment, particularly in that vegetative treatment area. The other aspect is additional permits were needed for Brattleboro zoning, and then in terms of consolidating the other solid waste permits at the site, this took extra time, but will be Bob's successors and staff will be quite grateful for this. Incorporated other aspects of the transfer station and recycling activities, household hazardous waste, waste oil. So all those things needed to be reviewed and updated so that a single master permit, so to speak, could be obtained from the state. So got to work, Bob and his team worked closely with Ben Gauthier and other at the state, and certainly that was helpful. They recognized, the state recognized that the facility needed to update and increase its permitted capacity, but they did not take any heavy-handed enforcement action as long as the district was demonstrating progress towards coming into compliance. No small detail is the Act 250 was also needed to be amended, so there was part of why this process took so long. Stormwater, looking at that again, it had to make sure that those drainages, some things are both practical for the site, having stormwater not run onto your working area to maintain dry working conditions, but also you don't need that upslope area from drainage from undisturbed vegetated areas and roofs to be directed into the vegetative treatment area. So trying to isolate and segregate those drainages took a lot of time to get the right pitches and angles, so there was a lot of cut and fill on the site and regrading and swales in order to direct water to the appropriate places. And this is all important, as you saw from those earlier maps, in the proximity to the Connecticut River. This is a public entity. Obviously, it's an environmental organization and wants to make sure that there's not runoff from the site that ultimately reaches that resource. So vegetative treatment area, again, this is it's a practice that's in the Vermont rules for composting sites, and it's essentially a grass buffer area. So the idea is any runoff that has nutrients or sediment from active composting areas has both infiltration of those physical particles as well as some nutrient uptake through vegetation. It's not a perfect system, but it provides a separation distance, and it's an alternative to having a full pond and basin with runoff. Because the site was relatively small, the area for standard uses did not match the criteria. So additional measures were needed. Basically around each of the piles, an additional wood chip berm was needed to be placed down slope of those to have immediate catchment of the nutrients and sediment that may come off of those piles, and therefore reduce the volume and intensity and strength of that. As a result, because this is a variance, I believe would be the right term, water testing is going to be taking place now that the facility has been built, to see how effective, in fact, it is. So that's something that we'll have more data on in the coming months, and work with the state to see if additional measures may or may not be needed. So leachate collection, leachate would be specifically, again, those liquids in contact with the raw food scraps coming in and the receiving and mixing area, and then with the active compost pile. So that's that brown juice typically of your any runoff. So having the enclosure makes a big difference in that primary area. So you're not getting the direct precipitation, so that really reduces the risks, particularly of pathogens, but also the risk of nutrients and sediment runoff. So on this site, it's a combination of the two. The primary stage, those first 4 windrows, first 4 weeks of processing is done under cover, and then the curing stage, the subsequent months, are out in the open. Those piles, in theory, are more absorbent, but they do have those additional high carbon berms on their downslope to try to catch as much of that as possible. All right, next, so going into this, as the design phase met all these criteria and had to meet all of these objectives, the bid process got underway. And that was also following all the development and funding pursuit that Bob and team did. USDA Rural Development was one of the bigger sources of funding, along with the Agency of Natural Resources and the Windham Solid Waste Management District Board approval. I believe there may have been a couple other small funding sources on top of that, but those were the major ones. As part of getting the USDA funding, it required a bid process. So Steve Horton Consulting, who Steve has done a lot of municipal projects from firehouses to other municipal projects. He oversaw this bid process and then was the clerk of the works or administrator during the construction process. The bid was broken into 3 work elements. So site work and excavating, kind of that grading of the site, meeting all the stormwater requirements, prep for the pads, the compost aeration system. Our team, AgriLab Technologies, got awarded that piece. So anything around the piping, mechanicals, through biofiltration, we were responsible for. And then ClearSpan Structures provided the hoop building that went over the primary composting area. And then, finally, after what seemed like forever, we got started. We got all the permits were in hand. I think the last one was Act 250. Was that the very last one? So I think we originally had hoped to start it back in 1994. I mean, probably, I think at one time we thought it may have been 2024, but yeah. Eventually, everything was in place and ground was broken. The building got erected in early November, and then we worked along with Zaluzny Excavating on our phases of work. So this is the sump tank that collects any of the leachate or condensate that may go through the aeration piping network. This is the equipment that our team fabricated up in Cambridge, Vermont. We're in the Cambridge Business Park off of Route 15. So we had our unit delivered down there to the site. And then we start connecting it to the piles. So again, our idea is we'll build all the mechanical units, the aeration blowers, valves, ductwork, the controls, sensors, all are mounted inside of the physical container, and then these ports on the side of the container connect to the pipe system that goes out under the compost piles. As this takes shape, those were the pipe ports on the side of the box, and we're under the building and building a push wall at the back. Originally, we wanted to have all the pipes in a concrete floor what would be called recessed channels, which would be the most efficient for loader operation, moving the compost in and out. One of the cost-saving measures was to defer putting the concrete floor down. So pipes on grade means you have a hardened working surface, in this case compacted gravel and stone, and pipes are set on top of grade, or pipes on grade. I really like this picture just because it's sometimes hard to imagine how the aeration process works, but these little 3/4 inch or 5/8 inch holes along 2 rows either side of the pipe are what's capable of drawing enough oxygen in and out of the pipes and into the piles to make the process aerobic, basically keep those 200-yard piles of compost in a state with enough oxygen where it's accelerating the process, it's controlling the process so it avoids odors, and in some cases we're recovering significant amounts of heat. Outside of that working floor, outside of the building, this is the biofilter. So this was not required from the permit, but Bob wanted to have a biofilter for several good reasons. Both you're dealing with food scraps, again, the potential for odors. This part of the facility is relatively close to the driveway. There's that Rich Earth Institute in the building behind there. So this is basically the exhaust from the piles. So after drawing that air out of the compost piles and the vapor, they go through this pipe network, and this is as it's being laid out, and then a bed of about 4 feet of bark chips was built on top of this. So given our timeline, winter came right in the middle of construction season, and we actually had a real winter this year, which was great on a lot of levels, but showing up on one of my site visits there, it was close to 2 feet of snow on top of the biofilter. Fortunately, there was one of these nice clear span structures over the primary composting floor, so we were fine there. But once the process started up, we were aerating the system, getting hot vapor out of the pile. A couple weeks later, it's all melted off, and there were not odors. So that was considered a success, and we're pleased with that outcome during the startup phase. So we're moving into operation, and this is actually the first pile. So pipes on grade, one of the common practices is to build a wood chip plenum over the pipe, and what that does is it spreads out the airflow at the base and center of the pile, and it also prevents some of the wet particles of the compost feedstocks from pushing and plugging into those pipe holes. So that plenum was built, and then here's the mix, those leaves, the food scraps, compostable bags, cardboard, about 175 to 200 yards. This is a few weeks later. A couple more piles have been built. You can see about 8 foot in depth, maybe 9 at the most, at the center of the pile. Try to line up the pipe in the center of the batch, and then they do touch at the shoulder. So this is what's called extended aerated piles. So it's space efficient, and it's also thermally efficient. There's less surface area, so you're not worried so much about losing warmth during cold periods. And as you can see, there is manual probes are showing up to 160 degrees. We're also capturing that temperature data on the vapor stream on the inside, but particularly early in the process, it's important to have kind of a manual verification of what's going on in the piles. Four zones. All right, so this is where all 4 zones are built. One of the things after the initial batch was built, Bob was like, we need a capping layer, and for multiple reasons. With those compostable bags in particular, if they're on the surface of the pile, they're not going to be moist and exposed to the decomposition process. So putting a capping layer on, this didn't get updated in this slide, but it's actually screened compost that's put over as a capping layer. So it's got some biological activity, and it helps maintain heat and moisture right to the surface of the pile. So there was much better degradation of those paper products and compostable bags and any other rollers or fruit and vegetables that may be at the edge of the pile once the capping layer was added. Here's a picture of Dick Petrie, their lead operator, covering up the piles. It's also more aesthetically pleasing. I mean, it certainly looks nicer to not have all the plastic, and I think it also helps reduce the risk of both the compostable plastic or contaminant film plastic drifting around the site, which is always a concern at any of these facilities. All right, so what's happening on the inside? Here's our, this is the blower that really does the work of that suction, lifting or pulling in most times pulling the vapor in to provide the oxygen. But as I explained, we can also adjust those valves in the back where you can push from zone 4, once it's up to a good oxygen level, into zone 3. And really that's the heat recovery part that we've implemented this site so far. And particularly during that cold weather, it helped jumpstart those processes. So that's, we then track that information through different pages. We can see it kind of in real time, as well as these trends. So this would be a roughly half-hour aeration cycle. We can see how when the aeration turns on, it's pulling in vapor around 120, and we get up close to 150. And then down here is the oxygen. So you'll initially see a dip in oxygen as you clear out the stale oxygen-deprived air from the center of the pile. And then as the cycle goes on, the oxygen level goes up, in this case around 10%. So we're able to track that and use that information to adjust the settings for how long the aeration blowers run, how much fan power is being used, and whether you're recirculating, pushing to exhaust, or pulling in fresh air to push into the piles. This is another page that helps the operators visualize which zone or windrow is being aerated to and from. So in this case, pulling out of zone 3 and going out into the biofilter for exhaust. And now spring has come. The vegetative treatment area has turned green. There's a stockpile of wood chips and leaves in the foreground, and there's the aeration equipment and the 4 zones of compost under the building. These are now the piles that have been through, at least a couple of these piles or what's been through the initial aeration phase, and we'll be seeing if indeed our projections will reduce this from an 8 to 12 month process down to a 4 to 8 month process or some other reduction in throughput time. Other parts of the site, this is just another view of the vegetative treatment area. Again, the slope of the site was all directed into this to be able to be caught again through those wood chip berms and then go through here. And then the clean stormwater, so roof runoff, upslope area, is directed into this stormwater basin. So that's sized with the runoff and drainage area. And then ultimately this goes to another basin and ultimately out to the Connecticut River. All right, so the challenge was how to do this without putting a burden on all the member communities. So these were the sources of funding that were obtained, both in-house and through the state of Vermont, USDA. Another EPA grant was applied for but not awarded. And then there's still more to do. So as I mentioned, that concrete working floor with recessed channels would be a big a big improvement, adding the heat exchanger for use here, not in heating buildings, but actually to heat the finished compost, dry it out a little bit to improve screening efficiency. That's always a log jam in composting operations. So that's the goal, is to be able to fund that in the near future and add more data collection sensors and see water as well. One of the ways to really optimize the composting process is to make sure it's sufficiently moist and not drying out. So that's another one of the process goals. These last couple slides are just to illustrate again, here's that energy resource that at most sites is just going off to the air. So we've been happy to have about 20 installations that our team has worked on where we're capturing this resource, and instead of putting it off in the air, we're putting it into this equipment and sometimes able to recover that energy. There's other ways to set up these systems. This one's in Michigan, but basically this would be the construction phase for putting channels in a recessed pad where you'd have a concrete or asphalt surface around that. This is an example of a drying system. So there's a negative aeration system in another part of this building, and then heated forced air is pushed up through finished compost piles before going through a screener. And at this site in Winchendon, Massachusetts, it like tripled their screening efficiency. This is, again, one of our other types of products that we offer. I'll go through that. I wanted to highlight this one in particular. We've been able to work on these medium and large sites for a number of years, but have not been able to offer a good solution to people who have asked for smaller farms, pilot systems, smaller scale, community operations. And now we've got several of these out in use, and a new one being built for a farm in Weston, Massachusetts currently. But there's a lot of opportunities here. It's like to say that this could be standard in the industry at some point. I would love to see that happen. It's a whole other energy resource that most sites aren't taking advantage of, and it can both help the process itself, but also add value for other activities, whether that's just heating buildings, offices, and greenhouses, or other enterprises on a site. Also important, and Alex, this is the one I was telling you is coming, is one of our sites out in Michigan. They had this artwork done. We are not that good of artists yet where we can do this ourselves, but we'd love to decorate that plain yellow container sitting in Brattleboro now with some rainbows and compost propaganda and other lovely education. So if you know some compost-aligned artists, connect with Alex Lacey, myself, Bob, and we'd love to get some great artwork put on that, because it's a high visibility area as people drive into the site, and just another way to educate people about all of this. Thank you.
Is this working? Yeah. Thanks, Brian. I just want to add the, a thank you actually to our staff at A&R. It was a complex project. It started different phases. Did we have money? Did we not? I need to scale it back. Oh, no, we got to do that. But through all that, we were able to maintain a really good working relationship, and I really appreciate that. It was not an easy project. It was 7 years from starting the planning to actually coming online. I also want to say it's performing as AgriLab has designed. The material, after it's been 4 weeks in an aerated static pile, is significantly visually degraded more than the pile that's sitting out that's just getting turned with a loader every, once a week or whatever. So the paper's not visible, the cardboard's pretty much disintegrated, and you don't see any obvious food. There's no attractant for animals or vectors, and there's hardly any odor. It's just kind of I call it a pipe tobacco smell. It's kind of nice, a little earthy. So the biofilter also, we used bark from a debarking machine at the sawmill right across the street from us instead of wood chips. And I must say the bark is fantastic. I worked with a biofilter engineer that I've worked with for many years who really likes bark because you've got long stringy pieces that have good porosity, but you also have a lot of surface area for the microbes because it's literally a septic system for air. You put this on top of the pipes. There's a residence time of approximately 90 seconds for air, and you get over 90% destruction of odorous compounds in that biological system. So that's performing really well. We're in an industrial zone in the town of Brattleboro, which allows in the zoning bylaw for composting, but you also can't stink up your neighbors. So I was really committed to having an odor control system, even though it was not required. I think we can open it up to questions if anyone wants more details. We're having a tour tomorrow at 10 as part of VORS I think there's about a dozen people signed up. Jason and I will be there. We're also having a grand opening for the public and the press on May 8th at 3 p.m. My board meets later that afternoon at 5, so we're really happy with the system. So, questions? John?
Well, I was just curious about your marketing strategy for finished compost. What do you anticipate doing with that?
Well, first of all, we've been composting food scraps there since 2012. And we have sold all the compost that we've made there. As a matter of fact, right now, I'm worried about running out of compost because we've had a favorable spring weather. Last year we had very wet period, and it's like farming. If people are doing gardening and lawns and stuff, you sell more product. We have 5 distributors. We don't sell to small buyers coming in with a little pickup truck or whatever. So we have 5 lawn and garden center distributors, 1 in New Hampshire and 4 in Vermont. And they're geographically spread. And we sell it to them for $30 a cubic yard. That's the wholesale. They then mark it up anywhere from $50 to $65 a yard. So they love our product. We have annual testing per our permit. The lab that I use in California does bioassays, just like we heard that Chittenden does in their own greenhouse for batches. We have done our own bioassays, but I had 100% germination from the samples that I sent. There's also a respiration and oxygen uptake test to characterize whether it's stable or not. Is it still biologically active? So we branded it Brattle Grow Compost, and we do print and radio promotion on it. We donate hundreds of cubic yards to schools and school gardens, and it's very popular. Of course, we're giving away 2, 3, 4 cubic yards, and but we do a lot. Alex Lacey, who does our outreach and education, I think she's probably done 20 school presentations in the last 3 months or more, right? And the students in Windham County all have grown up for probably 20 years with composting in their cafeterias, and it's continuing. So we tie the sale of the product to the generators, and they get it. And people are very conscientious. One thing I didn't really point out is that Brattleboro has curbside collection of food scraps. They have since 2013. And I was very skeptical that we'd have a quality that would turn into marketable product. But we have probably 3,000 households that participate. We don't really know because we don't go out and do a survey of set out rates of compost, but there's 4,000 households in the program, and if we said 3/4 of them participate. And they are so conscientious. It's just, and I think part of it is they're tied into using the material. But we get phone calls, can I put nail clippings in? What about Q-tip swabs, you know, and on and on. But people want to divert as much as they can. Brattleboro has pay as you throw, so, and there's no charge for recycling or compost. So there you go, do you buy a $4 bag and put your pizza boxes in that, or do you put it in your compost bin? So it's been a very good product for local lawns, gardens, and we do have some farms. We also have some flower growers. We have cannabis growers. We also take in a fair amount of cannabis byproduct, which is part of the state mandate now, just like food scraps. There's something like 20 growers licensed in Windham County. And there's multiple processors. So you get root balls, you get stalks, you get leaf and flower trimmings, and it's made inert. By statute, they have to mix it with dirt or kitty litter or sand or something so that it's not a useful product anymore. So anyway, good question, John. I couldn't understand that.
The question was the increase in permitted capacity, what the new facility allowed, and then what the capital.
Oh, yeah.
cost
Well,
was.
in Vermont, it's done by cubic yards. And so we were 2,000 cubic yards of food scraps per year under the small. And now it's 5,000 cubic yards. But because we take in paper products with it, we spent many hours 2 years ago figuring out from each generator what percentage was paper and cardboard versus food, and so that we could have a fairly accurate estimate of how much, when we get a ton from, say, the bread manufacturer, it's got far more food proportion than a ton from a commercial restaurant route or school cafeteria route, which has a lot of paper and cardboard. So we are, I think, set for quite a few years with that permit, but it wouldn't be that hard to go to a large, but I don't think we'll need that.
And in terms of the capital cost, I think it was just shy of $800,000 for all the site work and excavating, engineering, the aeration system, and the building, and any other incidental costs.
About $800,000 for everything. So, but we thought we were going to be able to put in a concrete slab and some other things for that amount of money. But as Brian said, prices went way up over the last 5 years.
Finished products that you changed the process?
The question is change in any of the finished product. So startup was in the first week of February, so there's no finished product yet. I think the windrows have made it out into the curing stages.
I actually just screened some of the product that came out of the building about 6 weeks ago just to see, and it's definitely much farther along than it had it not been through that 4 weeks of aeration. I mean, basically, those piles are cooking at 140 to 160 degrees, 24/7. And also what we've learned, and Brian knows this through some of this, is that there's an advantage of doing positive aeration and negative, cycling back and forth. It seems to enhance the microbial activity, so that it probably has to do with this type of bacteria. There's facultative bacteria that can be either aerobic or anaerobic, and then there's full aerobes and there's full anaerobes. So I think we have a very robust microbial population.
I'll add to that, just say that one of the premises for any aeration system, ours or any other technology, is that when you're just turning it with a loader, the turned windrow process of 5 times in 15 days or other intervals, you've got those 3 days at least where it's idle, and you may still have oxygen-rich layers at the outside of the pile, but fun fact is in the middle of the compost pile, when it's really active, it could run out of oxygen as little as an hour. So when you're on a timed aeration system, 10 or 12 times a day, it's getting air pushed or pulled through there. The other thing I'll add is the one other change in process dynamic is you move a lot more moisture. So there is a risk that you can over dry these piles when you're moving that much air through. So there has to be an effort up front to make the batch a little bit wetter than it probably started in a turned windrow process. And then ideally get water service in the future to be able to, if there was a dry batch, be able to amend that and make sure all those bacteria have a good habitat to do that decomposition.
Yeah, Chittenden, and they've been doing aerated static pile for 15 years plus, and they did have an issue with over drying after the aeration zone and then going into a secondary aeration, and so they would add moisture right in the past to the piles. We have not had to do that. We've been hitting our target moisture pretty good. We didn't mention this, the sump pump that collects the condensate that drops out when cold air is contacting hot compost, and also the leachate, which percolates down when you're pulling, is all collected in a 2,000-gallon tank. We then have a sump pump in there that pumps that, and we use it to irrigate and moisten a pile. So we put 1,000, 1,500 gallons into a pile in a matter of like 20 minutes. So we have that way of, but we only do that in the pre-PFRP days, because after you've gotten your pathogen kill, you don't want to then put highly, bacterially active leachate into the pile. So we're learning. I mean, there's so many variables: positive, negative. How many hertz is that fan running at? From 5 to 60. The airflow is tremendously variable. Also, timer: how many minutes on, how many minutes off. So I've got a lot to learn. And we're going to contract with AgriLab for a period of months to continue to help us do this. So I'm excited. Be glad to show you around.
Are you
Hey, yes.
piles? Are you the one that's like watching all of the like the airflow or
Yes.
control over that?
Yes.
Is that like a daily thing or is that like
It's real time. Right now, you can look and see what the.
noticing the constant
Yes, you have to then make a manual adjustment. One of the phase 2 goals would be to have automated temperature probes that would then control the fans, and that could be a feedback when the temperatures drop. You want to add more oxygen, or if they get too hot, draw more air. And that's in the future. And yeah. She's asking how long will our biofilter media last. We don't know. But one thing I'm putting in an add-on is a back pressure sensor just for the biofilter. We do have an overall pressure sensor, but it's both positive and negative, so I don't know exactly what the biofilter constriction is. But as the back pressure increases, that means it's decaying, but the airflow is really great through it now. But literally, the sawmill is right across the street. Yes, it will be, and so I'm thinking that we'll get maybe 2 years out of a batch. I haven't seen any subsidence, but I do check the temperature, and it is active. It's in 120, 130 in the biofilter. So it's another thing I don't know the answer to yet. But thank you, everyone.
Thanks so much, Brian and Bob, and also Allison and Kim. And this concludes the final session, but you're welcome to continue networking and visiting the exhibitors until 4. And also, Natasha wanted to remind everyone to please leave your name tags at the registration table, and then if you're looking tomorrow, you'll receive the evaluations in the email. And so your feedback is really appreciated. So thanks, everyone.